Hello everybody, I am Amit Maru and today we are going to discuss about a greedy algorithm. So in this video I will give brief idea about what is greedy algorithm is with one example, that is a minimum spanning tree by using greedy algorithm. So let us start our today's video on greedy algorithm. First of all, what is greedy approach is, or we can say what is greedy algorithm. The name itself, greedy, suggests that it is a short-sighted method. It takes decision on the basis of information immediately at hand without worrying about the effect of this decision may have in the future. So in every stage we may have a number of choice, or we can say number of solutions, and we have to choose one best solution without worrying about the effect of that decision may have in the future, and so that it is known as greedy algorithm, or we can say greedy method. It is easy to invent, easy to implement, and when they work efficient. The greedy algorithm normally used to find the solution of any optimization problem. In optimization problem, we have a number of stages, and every stage we have a number of choices, and we have to choose one solution, or we have to take decision based on the information available, which is best one, without worrying about the effect of that decision may have in the future. So we can say any optimization problem can be solved by using greedy algorithm. As we discussed in our divide and conquer, we have one fixed template. In that we are checking that our instance of any problem is large or not. Whenever it is large, at that time we are dividing our instance into different small parts, and we are finding solution of every small parts. At the end we are merging solution of every part, and this method simply known as divide and conquer method. Likewise, in a greedy algorithm we have one fixed template to find the solution of any problem by using greedy algorithm, and sometimes it is also known as general characteristic of greedy algorithm. So let us discuss about the template of greedy algorithm. In this greedy algorithm, or we can say in function, we have to pass d, that is the domain which has a size n. So this domain d is nothing but a set of solution, or we can say sort of information. From that we have to choose one by one information, or one by one solution to find the solution of our final problem. There is one solution set, in that we will store our solution. Now as we discuss, D is a domain in that we have a multiple choice of different solutions. So select one solution from the D and store inside the S. Then we need to check whether this solution is feasible or not. If this solution is feasible, then store inside one solution set. If it is not feasible, then we have to find a second choice. So every stage we have to identify one best solution, and we have to store inside the solution set until we get solution of our final problem, and then we have to return solution. This is the simple method of greedy, in that we are finding solution of any problem, right? And because of this system, it is also known as greedy, and it is a short-sighted method. Just take one example so that you can easily understand how greedy can find the solution of any problem. Our first problem, that is a spanning tree. So first of all, you must know what is the definition of tree. Tree is a acyclic graph. If we have one graph, in that a number of cycle or number of loops available, if we remove all the loops, or we can say all the cycles, then this graph becomes a tree. So simply we can say tree is nothing but a cyclic graph, in that there is no cycle. So now what is definition of spanning tree? Spanning tree is a subtree of any tree, or we can say the subtree of any graph, in that all the nodes connected without any cycle. So one graph may have multiple spanning tree. Just take one example. Suppose there is one graph, in that different nodes connected through the different edges, and every edge has some weight, right? So every edge has some cost, or we can say the weight, and all the nodes connected. Now we can find the spanning tree of this graph, and same graph may have a number of spanning tree. Just take one example. Suppose this is the first spanning tree of this graph. As we discuss, all the nodes must be connected and there must not be any cycle. This is known as spanning tree. So for this graph, we can say this is the first spanning tree, in that all the nodes connected and there is no cycle, there is no loop in this graph. So we can say this is our first spanning tree. As we discussed, we may have a number of spanning tree of any graph. So this graph may have more than one spanning tree. Just take another example. Suppose this is also the spanning tree of this graph, in that all node connected and there is no cycle. So this is another example of spanning tree of this graph. Likewise, we can have a number of other spanning tree of the same graph, right? So a spanning tree, as we discussed, there all the node must be connected and there must not be any cycle. This is known as spanning tree, and any graph may have number of spanning tree. Now our second thing is we have to identify the minimum spanning tree. So first of all, what is spanning tree, that we discussed. Now we have to identify the minimum spanning tree. So as we discuss, same graph may have multiple spanning tree. Like in this example, we have a 2 spanning tree, or we may have more than 2 spanning tree also. At that time, we have to identify the spanning tree which has a minimum cost, and this spanning tree is known as minimum spanning tree. Again, I am repeating, for any graph we may have number of spanning tree. Among this all the spanning tree, we have to identify the spanning tree which has a minimum cost. This spanning tree is known as minimum spanning tree. From this example, suppose we have a 2 spanning tree of this graph, then find out the cost of both the spanning tree. The cost of this spanning tree is 7. We have to just add cost of every edge. This is 2 plus 1 3 plus 1 4, 4 plus 3 7. So the cost of this spanning tree is 7, and cost of another spanning tree is, for example, 3 plus 2 5, 5 plus 5 10, 10 plus 3 13. So this is the cost of spanning tree, that is 13. When we compare this cost of both this spanning tree, then this is 7 and this is 13. So we can say this spanning tree is a minimum spanning tree, right? So for example, this graph has a 10 or 15, for example, spanning tree. So among this all the spanning tree, we have to identify the spanning tree which has a minimum cost, and this spanning tree is known as minimum spanning tree. Now, what is application of minimum spanning tree? The spanning tree are very important in designing efficient routing algorithm. In our network, when we design, when we make a routing algorithm, at that time spanning tree is very much important. So normally spanning tree is basically used to find the solution of many network related problems. Second one is spanning tree have wide application in many areas such as network design. When we design network of any organization, suppose at that time we have to design the network which has the lowest cost, right? So when we design network, at that time we have to find the minimum spanning tree so that we can reduce overall cost of any network. This is the application of minimum spanning tree in our computer field. Now algorithm to find the minimum spanning tree. We have basically 2 algorithm to find the minimum spanning tree. One is Prim's algorithm. Using that we can find the minimum spanning tree, and second one is a Kruskal's algorithm. This is also used to find the minimum spanning tree of the graph. Now the question here is why we have to use the algorithm to find the minimum spanning tree of any graph if we can directly find the minimum spanning tree. Because when your graph is very complex, at that time we may have a number of spanning tree, right? For some time our graph may have more than 100 spanning tree. So out of this all the spanning tree, we have to identify the spanning tree which has the lowest cost, and this spanning tree is known as minimum spanning tree. So it is very difficult to identify the spanning tree of any complex graph which is minimum spanning tree. So that we are using algorithm, and the best algorithm, that is 2 best algorithm. One is Prim's algorithm to find the minimum spanning tree, and Kruskal's algorithm to find the minimum spanning tree. So let us discuss our first algorithm. that is a Prim's algorithm to find the minimum spanning tree of any graph. As per the algorithm, the first step is select the pair with minimum weight, because we are finding minimum cost, the spanning tree which has a minimum cost, so that we have to select the pair which has a minimum weight. Second step is select the adjacent vertex and select the minimum weight edge using this adjacent vertex. The selected adjacent vertex should not form the cycle. So when we use Prim's algorithm, at that time when we select, for example, one edge which has a minimum cost, then second edge we can select which is directly connected with this edge. It means that we can select the next node which is adjacent node, or we can say the neighbor node of that particular node, and this flow is also known as natural flow to find the minimum spanning tree of any graph. Step number 3, that is repeat step number 1, that is select the pair which has a minimum weight, and second step, that is identify the next vertex, or we can say the neighbor vertex or adjacent vertex which has a minimum weight. So repeat both these steps until we get a solution, until we find the minimum spanning tree of any graph. Just take one example. Suppose we have one graph in that number of vertices are there. For example, total 7 vertices are there starting from V0 to V6. This graph is a weighted graph in that every edge has some cost, or we can say the weight. For this weighted graph, we have to identify the minimum spanning tree, and by using Prim's algorithm. So let us discuss how we can find minimum spanning tree of this graph by using Prim's algorithm. So as we discussed, we have certain steps that we need to follow to find the minimum spanning tree of this graph. And this graph we may have a number of spanning tree. Among that we have to identify the minimum spanning tree, but this Prim's algorithm will directly give the spanning tree which has a minimum cost. So let us discuss how we can find minimum spanning tree by using Prim's algorithm. As per the Prim's algorithm, the first step is we have to choose one node as a initial node. For example, V0 is our initial node, and then we have to identify the vertex which is adjacent node of this V0, or we can say which is neighbor node of V0. So adjacent node means the node which is directly connected with V0 node. So we have a 3 choice in this case. One is V0 to V1, V0 to V3, and V0 to V2. So as we discussed in our greedy algorithm, every stage we have a number of choices and we have to identify the best choice among that. So we have a 3 choice: V0 to V1 which has a cost 2, V0 to V3 which has a cost 3, and V0 to V2 which has a cost 1. Among these 3 decision, or among these 3 solution, we have to identify the solution which has a minimum cost. So here 2, here 3, and here 1. So we have to choose this edge, because this edge has a cost 1. So we are selecting V0 to V2 first. So this is our first selection, and this selection is V0 to V2. Now we have a 2 node V0 and V2, and we have to identify the next adjacent node which is either directly connected with V0 or V2. So V0 is connected with V1 and V3. So V0 to V1 has a cost 2, and V0 to V3 has a cost 3. Again we have to check the node which is directly connected with V2 also. So V2 is connected directly with V5 only, and V0 which is already has been selected. So we have a choice, that is V2 to V5 which has a cost 4. So among this all the choice, the first choice, that is 2, second has 3, and third has a cost 4. So among these 3, the 2 is the minimum cost, so that we can choose this edge V0 to V1 which has a cost 2. So next choice, that is V0 to V1. Now identify the node which is directly connected with V0, V1 and V2. Among that we have to identify which one is minimum. So V1 is connected with V4 which has a cost 6, V1 with V3 which has a cost 6, V0 with V3 which has a cost 3, and V2 with V5 which has a cost 4. So this is 4, 3, 6 and 6. So among this all, the 3 is the minimum cost, so that we need to choose V0 to V3. So our next choice, that is V0 to V3. Now we have to identify the node which is directly connected with either V0, V1, V2 and V3, but every time we need to check that there must not be any cycle. So now we have one choice, that is V1 to V4 which has a cost 6, V1 to V3 which has a cost 6, V3 to V4 which has a cost 5, V3 to V6 which has a cost 5, and V2 to V5 which has a cost 4. So we have a two option, one is V3 to V5 which has a cost 4 and V2 to V4 which has a cost 4. But alphabetically if we consider, then we have to choose V2 to V5. So our next choice, that is V2 to V5 and the cost is 4. Now we have a different choice again. We can choose V5 to V3 which has a cost 4, but here we cannot choose this one because it creates cycle. So when we connect V5 to V3, it creates one cycle. So cycle is not allowed because we are finding tree and the tree is a cyclic graph. So we need to check there must not be any cycle. So this path we cannot choose. Another option, that is V5 to V6 which is 3, V3 to V6 that is 5, and V1 to V4 which has a cost 6. So among these 6, 5 and 3, minimum is 3. Here V1 to V3 we can also have one choice, but we cannot choose because it creates cycle. So we have only 3 choice, that is 6, 5 and 3. Among these 3 we can choose minimum cost, that is 3, that is V5 to V6. So our next is, that is V5 to V6. Again, find out the node which is directly connected with V3, V4, V1, V4 and V6, and there must not be any cycle. So V1 to V3 we cannot choose because it creates a cycle. V3 to V5 we cannot choose because it creates cycle. V3 to V6 we cannot choose because it creates cycle. So we can choose V1 to V4 which has a cost 6 and V6 to V4 which has a cost 5. So among these both the choice, the minimum cost is 5. So we can choose our next as, that is V6 to V4 or V4 to V6. Now we have to identify the node which is directly connect with V1, V3, V5, V6, V4, V0 and V2, but there must not be any cycle. So there is no any option because V1 to V4 we cannot connect, it creates cycle. V3 to V5 we cannot connect, it creates cycle. V3 to V5 we cannot connect, it creates cycle. So now there is no any option which we can choose and it not create cycle. So this is our spanning tree, and this tree is also known as minimum spanning tree. Find out the cost of all these edges, then we can say it is a total cost of minimum spanning tree, and the answer is 18. This type of question will be there in your examination. In that we have to identify total minimum cost of any tree. So first we have to identify the minimum spanning tree and then calculate the total cost of this minimum spanning tree. So in this case the cost of the minimum spanning tree is 18. Take another example so that you can easily understand. Find out the minimum spanning tree of this graph. This graph is also weighted graph, and normally we have to start alphabetically, or if it is a number then it must be in ascending order. So for example, our initial node is A. If initial node is not given in your examination, then you can start alphabetically. So in this case initial node not given, so that we are starting from A. So as per the steps of our Prim's algorithm, we have a three choice, that is A to B, A to F and A to E. These are the three different neighbor node E, F and B. Find out the minimum cost is A to B has a cost 16, A to F has a cost 21 and A to E has a cost 19. Among these three, the 19 is a minimum cost, 16 is a minimum cost, so that we can choose A to B first. So our first edge will be A to B, which has a minimum cost. Find out the next node which has a minimum cost. So we have a different choice, like A to E we can connect and the cost is 19. A to F we can connect, which has a cost 21. B to F we can connect, cost 11. B to D we can connect, cost 5. B to C we can connect, cost 6. So these all are the different options. Among that we have to identify the best one. So first choice, that is 19, then 21, 11, 5 and 6. Among these all, the 5 is minimum, so that we can choose next node, that is D, B to D, and the cost is 5. Now we have to identify the node which is directly connected with either A, B or D. Among that we have to identify which has a minimum cost. So here we can connect A to E, which has a cost 19, then A to F, which has a cost 21, then B to 11, which has a cost 11, B to C, which has a cost 6. So among these all, this edge has a minimum cost, so we can connect B to C, which has a cost 6. So find out the next node which is directly connected with either A, B, C or D, and find out the edge which has a minimum cost. So now we cannot connect C and D because it creates cycle, so we cannot choose this edge. Find out another edge. The B is connected with F and the cost is 11. D is connected with F, cost is 14. A is connected with E and the cost is 19. So this is 11, 14 and 19. Among that 11 is minimum, so the next node we can connect B to F, which has a cost 11. Again, find out the node which is directly connected with our A, B, C, D and F, which has a minimum cost. So we have a different choice, like F to D we cannot connect, it creates cycle. D to C we cannot connect, it creates cycle. So F to A, or we can say A to F we cannot connect, it creates cycle. So we have a choice like A to E we can connect, and the node edge is 19. F to E we can connect and the edge has a cost of 33. D to E we can connect and the cost is 18. So definitely we can connect D to E, which has a cost 18. Now there is no any chance where we can connect our node through any edge, because it creates cycle everywhere. So we have to stop here and find out total cost of this graph. And this graph is known as, this tree is known as minimum spanning tree. Find out that sum of all the cost, so that we can say that total minimum spanning tree cost is 56. So in this way we can find minimum spanning tree of any graph by using Prim's algorithm. So there is two methods as we discuss. One is Prim's algorithm, in that we are finding minimum spanning tree. Second algorithm, that is Kruskal's algorithm. Later on we will discuss how we can find a minimum spanning tree by using Kruskal's algorithm. In both the cases we will have a same solution, same cost, that is minimum cost of minimum spanning tree. So this is all about how we can find minimum spanning tree of any graph. So this kind of example will be there in your examination, in that one graph will be given. This graph will be definitely weighted graph, and you have to identify the minimum spanning tree. You have to mention all the steps how we can find minimum spanning tree by using Prim's algorithm. So now let us discuss the time complexity of Prim's algorithm. As you know that we can represent any graph by using either matrix or by using adjacency list. If we represent our graph by using, for example, matrix, at that time number of rows and number of columns is depends on number of nodes, number of vertices. In our graph, for example, we have 4 different vertices or 4 different nodes, then the matrix will be 4 by 4, that is 4 rows and 4 columns. To fill this matrix, definitely we will have a nesting of loop. One is inner loop and second one is the outer loop, to fill this matrix and to find the minimum cost, minimum spanning tree of any graph. So definitely the time complexity of our whole algorithm will be order of v square. This v indicates number of vertices, right? But when we represent our graph by using adjacency list, at that time it can be we can find the solution by using binary heap also, so that we can say the time complexity can be reduced if we use adjacency list to represent our graph. Then the time complexity can be reduced up to the order of e log v. Here e indicates edges and v indicates number of nodes, right? So the total time complexity, if we represent our matrix our graph by using adjacency list, at that time the time complexity will be order of e log v, right? So this is all about what is time complexity of our Prim's algorithm. Thank you very much.